area, 34 million people we have. In New York area, more than 20 million people. So, more than 20 people, 20 million people. Likewise, Mumbai, Jakarta, Delhi, Mexico City, Sao Paulo, Manila, Osaka, Kobe, Kyoto area, Cairo, Los Angeles, Calcutta, Shanghai, Moscow, Buenos Aires, Beijing, Shenzhen, Rio de Janeiro, Istanbul, Paris. So those cities have more than 10 million population, which is called as megacity. So those megacities are located all over the world, especially in Asian region. There are many, many megacities, as you can see here. This shows the projection or forecasting of world population. This also indicates the differences among continents. So you can see Asia and African region in the future, population will increase very much. This graph shows global environment change or climate change. Global environment including population growth or industrialization or urbanization. And also, as you know, climate change or global warming is very important. So those kind of changes in the world is global environmental change or global climate change. So those change increase disaster risk by amplified water hazard. Sometimes you hear that in the future, by global warming, typhoons become bigger and rainfall intensity will be increased. So to cope with this kind of increase of disaster risk, it's better to establish adaptive capacity for high resilient society. Usually, the governments invest much money to infrastructures, for example, dams, levees, or river improvement, and so on. And also risk assessment and societal awareness is also very important. And resistance against disasters or hazards is also very important. So human resistance or social resistance is very important to cope with disasters or hazards. And also anti-disaster immunity. So once you may be suffered from a hazard, but next time you should control or you should reduce the risk of disaster. Of course, people are doing something against hazard or disasters. And we have some culture or custom in the region against hazards or disasters. In university, for example, our Disaster Prevention Research Institute is implementing natural hazard science. And also, we are considering implementation science for disaster risk reduction. Disaster risk reduction here, DRR. And in the university, based on those sciences, we are doing education for disaster risk reduction. This yellow colored portion is the role of our university. And in such kind of science and education are contributing to preparedness and adaptation. And finally, establish adaptive capacity and high resilience society to cope with increase of disaster risk by amplified water hazards. So for Japanese students, I made this Japanese version. You can see what I said in English. But, later you can see that. Okay. This shows various patterns of extreme events and disaster-resistant capacity. For example, by global warming, rainfall intensity is going to be increased, like panel A, but the societal capacity or disaster-resistant capacity in the society may be constant in the future. Then you may often face the floods, for example. Or sometimes it is said that in the future, fluctuation will become higher and higher. So in that case, you may face not only floods, but also of droughts, for example. In panel C, this means decreasing disaster resistance capacity. The capacity is going to be small because of aged society or aging society or deterioration of the environment or degrading of the facilities or infrastructure. In that case, you may face more floods and droughts. Panel D shows the abrupt change or very huge earthquakes or floods sometimes occur something like this. So after the earthquake occurs, we upgrade our facilities, something like this. Then another event comes. Then again we will upgrade our facilities or infrastructure. Such kind of capacity enhancement is taking place in many areas. So today is the 17th of January. Do you remember? I don't know. Yeah. 16 years ago, we had a very big earthquake in Kobe. Just today, in the morning today, 16 years ago, 1995. At that time, I was, my home was near here, in Okazaki area. And my house was also very much shaken, and some grasses were broken. Fortunately, my family was not injured by the earthquake. Anyway, such kind of, this slide shows the relationship between disaster resistance capacity and extreme events. Panel E shows the gradually increasing hazard, like water quality in a pond or lake. The water quality is gradually increasing, gradually being deteriorated. If we take good measure, the situation will recover. But if we don't do anything, it will go up. And this is a hazardous situation. So there could be various patterns of extreme events and disaster resistance capacity indicated here. So again, please consider this graph shows the river flow. And this blue colored portion is a societal capacity. And